Hey, good evening, friends. Since only it's 3 minutes past time, I would prefer to start with a very brief chat about uh, I, IC and IT first. So feel free to let me know if there is any questions about this first. Thank you. Um so, welcome all. We just quickly run through a very brief introduction about IC. IC is, as you know, is Institute of Civil Engineers. We are a 200-year-old organization with 95,000 plus members across the globe. Uh, I hope you're able to see my screen. Can you please confirm that you're able to see my screen?
Yes.
Okay, great. Thank you very much.
Yes,
So,
Rajesh.
okay, great. So, as I mentioned, IC is a 200-year-old organization with 95,000 members. That information that you see on the slide is slightly dated, but it's a professional qualifier for civil engineers and has been around for quite some time. It's affiliated to the Engineering Council of UK, and we uh, we conduct multiple different activities across the globe for the benefit of members. Primarily, it's a not-for-profit organization run for the benefit of members by the members. And as you see on the screen, there are various benefits that members are able to avail. Again, as the Mumbai regional representative, if anybody has any questions about what IC does, feel free to approach me, and I'll be more than happy to help. So if you look at IC, very similar to any other professional institution across UK, we offer various levels of membership, so which includes student memberships, graduate memberships, followed by a full membership, and the highest grade, which is a fellow membership. We also offer technician membership to engineering technicians as well. What this actually would mean for every single level of engineer will depend upon how you're connected, what is your background, and so on and so forth. So feel free to approach me. Those are my coordinates. I'm also happy to share that I'm one of the 3 approved mentors within the Mumbai region itself. So if anybody has any interest in working through your professional qualifications to become a chartered member of the institution, I'll be more than happy to support. Or if I am too busy, I can actually put you across to other mentors who can help you with the process itself. Uh, Within the Mumbai region, we are conducting multiple different activities. The one that you see on the screen is a Genesis. This was a live event we conducted uh, a year or two back. We have changed the format of delivery of these sessions. In the recent times, we have done more of online session. The one that we are seeing right now, primarily a webinar based, because of the fact that we have appreciated the issue of people having to commute, and commuting has been a big issue in Mumbai in the recent times. So in appreciation of that, we have changed our mode from live sessions to webinar sessions during the recent times. So feel free to connect with us if there is any question, any suggestion on the topic of discussion, or any specific speaker you would like to hear through these live webinars that we conduct. Feel free to let me know, and I will be more than happy to support to the extent possible. Uh, we also conduct various site visits. So we have, in fact, just this year, last month, we did a tunnel site visit to a tunnel construction being done by L&T. And I'm quite happy to share that we are actually very well connected within the industry. We have got some reputed consultants on board. We have got reputed constructors on board with IC, who are also a part of the Mumbai Association, and they are actually helping us provide direction to what IC should do in Mumbai, and how we can connect better with the civil engineering fraternity within India. What kind of activities will actually help us and our professionals gain better benefits out of being members of IC or being associated with the IC in any way. So feel free to share your thoughts. If there are any suggestions, we are more than happy to welcome any suggestion from any of our members or otherwise as well. So that's sort of a brief introduction to IC itself. I will now also share a very brief presentation about another professional institution called the IET. Uh, so I hope to put that across right now. Just bear with me for a second. Um, I am having some issue getting the other presentation on board, but I think I'll just quickly talk through this. Um, this particular session, the Genesis, is also combined with another session called TechDais, which is typically a flagship event conducted by IET. This particular session is actually brought to you by a combined effort put across ICE, the Institute of Civil Engineers, IET, the Institute of Engineering and Technology, and AWWA with support from Black Veatch as well. So AWWA, as you know, is American Water Works Association, and Owais will probably briefly touch upon what that institution does within India and how we are trying to work together to bring the best for the benefit of the civil engineers in the region itself. I'm also quite glad to let you know that we have seen a significant rise in the interest of civil engineers to get connected to the activities that Mumbai region has been conducting. We have had multiple events where we have had, uh, professionals attend our sessions from UK, across Middle East, India, and in fact, we also have some people from Hong Kong and as far as Korea as well occasionally join our session. So I'm quite proud to say that this particular event um, has been helping professionals connect with us on a regular basis through this kind of platform. So with that brief welcome, I now request Owais to commence his presentation without wasting time, and let's sort of hear all from Owais now. Owais, over to you. Thank you very much.
Rajesh, can you hear me?
Yes, I can.
Okay. So good evening, everyone, and thank you, Rajesh, for organizing this. I would also thank AWWA, ICE, and IET for giving me this opportunity. My name is Owais Farooqi, and I am a volunteer for AWWA. AWWA stands for American Water Works Association. For those of you who are not familiar, it is the largest professional association for water professionals in Northern America. We do have a section here in India with about 300 plus members. And we do a lot of thought leadership besides we promote activities related to water resource development, water utility work, and a lot of knowledge sharing. There are some training programs specifically that we do for water and wastewater utilities. And those training programs are primarily based on US experts coming down here and training people on specific subjects. So I will not take more time for introducing AWWA. For those of you who are interested, they can check AWWA website for all information, or they can surely reach out to me, and I will be happy to connect in that forum. So I'll bring you back quickly on our presentation. So today the topic is managing water supply, water conservation, demand management, and reuse. The reason why we are talking about this subject, because we are approaching summer, and this subject will be in media in different forms, although none of the media channels or even technical forums cover it fully to help us understand what exactly all these terms mean. So one of the purpose of this presentation is that whoever are the listeners today, they can develop develop some sort of understanding of what these terms mean and what is the minimum we need to have in place to talk about viability of these programs. So that is sort of the purpose. Let me see how much I can accomplish that. But I will start with the thought that we all know that water is a very finite resource, and the entire world is challenged by global changes in climate, which has really posed a lot of challenge for planners on how to plan water supply and how to forecast things. Now, at a national scale, which is talking primarily about India, the scenario is that besides those global challenges, we do have some additional challenges, and those challenges are we are as a society not very effective in terms of using water efficiently, and at the same time we are having a rising population, which means we also have a rising demand. So all these challenges put together poses a big threat to the civilization, if not now, maybe a few years down the line. Now, what happens is every now and then when we experience a situation where there are water shortages, we do hear that someone should be recycling the water, someone should be doing conservation. But as I said earlier, things are probably not in place or not sufficiently planned to get these programs going. Now, with this thought, I would just introduce the agenda of today's presentation. So primarily, I'm going to be talking about water conservation programs with respect to AWWA M52, which is a manual published by AWWA in America. Now, the concepts are quite universal in nature and can be applied with some degree of modification. But most of the presentation that I will do, I will try to draw some references from this manual. And then I will talk about some other manuals in between, as and when required, which are also manuals from AWWA, along with some global examples, which will be primarily Singapore and OCWD, which is Orange County Water District, to convey what these programs mean. So this is very briefly about the agenda. And once we finish all that, I have about 22 slides. Once we finish all that, I expect that we'll have some time left for discussions, which is really the most important part for these sort of events, that we need to deliberate on things so that we can take this forward. So before I get into the definitions of what is the conservation, let me just differentiate between long-term and short-term conservation measures. Now, long-term conservation measures are essentially lasting, and they tend to have more influence on the behavior change of the society. And that is why these long-term changes are really the measures that we can put under conservation. So whenever we talk about water conservation programs or water conservation measures, we talk about long-term measures. Now, the short-term measures, on the other hand, they are very temporary in nature. For instance, you have a shortfall in your supply and you start restricting the supply from a 24-hour to a 8-hour supply. And as soon as you have your supplies established, you sort of ramp it back to 24-hour supply. So that's more of a short-term conservation measures. And these type of measures are typically used and deployed during drought or some emergency situations. So another example of a long-term measure could be, watering of lawns. So many of you who live in housing societies or in your own individual house may have experienced that the irrigation in the lawn is typically, a very behavior or habit type of thing. I mean, if I am an individual who wants to get up at 5 a.m. in the morning and water my lawn, I would do that as a part of my daily routine. There are people who do it at noontime, and then there are people who do it in the evening. So it is very individual behavior oriented practice. Now, by applying conservation or going on a conservation program, those habits essentially may have to change to suit the needs of the program or to meet certain goals. So those measures, will be qualified and characterized as long-term measures. Now, with that differentiation, I would like to clarify that M60, which is another manual for drought preparedness and response, we are not going to talk about that. Now, that's a manual which is available on AWS website. If you're interested, you can definitely go and check it out, and we can talk about that at some other point. So now, talking about water conservations, definitions. So if you Google, you'll probably find, 1,000 or maybe more than 1,000 definitions of water conservation. And you may find, multiple websites using terms which are like conflicting with each other, or they're repetitive in nature. And, honestly, few years ago when I was learning about all this, I was quite confused. So one has to really dig deep into the definitions to understand what exactly is water conservation and what is demand management and how are they connected. Now that may sound very complicated, but I'm going to simplify it very quickly for you. So as per the code of water code in California, demand management and conservation, these are the terms that are used interchangeably. So it is more or less the same thing. So when you say demand management or water conservation, these are not different. Essentially, they both talk about measures, programs, or whatever policies you have that promote reasonable and efficient use of water. Now that's the definition in the code of water code of California, and they have also described efficient use as those management measures that result in effective use of water. So in a nutshell, two things come out of it very clearly. One is conservation and demand management are essentially the same, and they both essentially consist of a whole lot of measures that are geared towards effective use of water. That is what Californian code says. Now, if we go to Texas, which is another state in the United States, California and Texas are probably the biggest and largest states that have conservation programs, so I've chosen those definitions. In Texas, the code is also giving definitions similar, but a slightly different manner. So they talk about two things again. The first is development of water resource. Now, appreciate that Texas is a state that is more like a desert. So any development of resource that provides them a long-term use or a reliable resource is obviously considered as a water resource conservation measure. And then they have clubbed all the other techniques and technologies under the efficiency part of it. So essentially, Texas is defining it slightly differently, but again, talking about resource development and then efficiency. Now, if I go to other states, I may find different variations. And, if I go to Singapore and Hong Kong and, other geographies, probably the definition will vary to some extent. So instead of defining water conservation in 50 different ways, let us stick to AWWA M52 definition, which essentially makes it even more simple. So the first part is all the improvements, fixtures, and equipment technology that is geared towards efficiency, which is the efficient use of water part. And the second part is all the actions that lead to long-term behavioral changes. Now, long-term behavioral changes covers a whole lot of things. It talks about the habits, the behaviors, the acceptance of new practices, the acceptance of modified way of living, a whole lot of things. So AWWA definition becomes a little bit more holistic, and we will accept that. Going forward, we will use water conservation as a definition defined in AWWA, which is anything that leads to behavioral changes plus anything that talks about efficiency, fixtures, equipment, etc. So hopefully that simplifies a few things. I hope I have not confused people more, but we can probably talk about that a little bit more. And once I run through the presentation, things will become a little bit more clear. So with these definitions, we move forward to the key elements of water conservation program. Now, this slide shows you 5 key elements, which are legal, instruments, community, institutional, and financial. Now this slide, please remember this slide because I'm going to come back on the slide several times during the presentation. But this slide contains the heart and soul of water conservation program. If you really pick these 5 elements, you can get things moving on ground. Now, which means that we have to really dive a little bit deeper to understand what are these 5 elements. But again, I'm repeating, if you have these 5 minimum elements in place, you will have a conservation program up and running. So that's one of the takeaways from today's presentation. Okay. So now let's talk about the first aspect, which is the legal aspect. Okay. Now, legal aspect constitute of all federal, which is the central government, state, local policies, regulations, ordinances, guidelines, or any sort of thing that is a binding on the utility. So, for instance, if you have a plumbing code that requires you to use a certain type of water sort of faucet, or that restricts the use of certain users below a certain level, now that code becomes a part of your legal framework. Likewise, if you have a water supply regulation that requires you to have conservation as an inbuilt measure in your water supply plan, that becomes a part of your legal framework. A legal framework can also be, a good example could be, like you have some guidelines from a ministry. For India, probably it is Ministry of Urban Development, who have some guidelines that require 20% of recycling in developments beyond a certain size. So if there is a housing society above a certain footprint, it is mandated by Ministry of Urban Development that they use recycle water to a certain extent. Now, these are the legal measures. So let's take an example of United States and try to understand what type of legal measures are there. So the document on the right that you see, it's a water conservation plan guideline, which was issued by EPA. So there was an amendment in Safe Drinking Water Act in America in 1996 that mandated that EPA prepares and publish some guidelines within the 2 years of that amendment for conservation. So you can imagine, like, we're talking about 1996, which is not very far. So America's first guideline rolled out in 1998, okay? Now the guidelines are primarily based on climate and availability of water. So they are not binding on any of the states. They are a condition. They basically state some conditions that if a state is going for some sort of funding from a federal fund, then these guidelines sort of become a binding. Now, unless and until they go for money for state revolving funds and stuff like that, these guidelines are just guidelines, and the implementation part is primarily left on the states. Now, when the Safe Drinking Water 1996 amendment came in, the request specifically was to create guidelines in 3 categories. One was below 3,300 connections. The second was between 3,300 to 10,000 connections. And the third was more than 10,000 connections. So when EPA developed these guidelines, they created their own categories. So what they did is, for up to 3,300 connections, they said, these are just, set of practices that you need to follow. Now, then between 3,300 to 10,000, they said that you need some basic guidelines. Now, basic guidelines are basic. We are going to talk about that. They don't have a whole lot of advanced level measures. And then between 10,000 to 1,000 persons, they said, go for intermediate. And above 10,000, above 1 lakh, they talk about advanced guidelines. Now, once again, the implementation of these guidelines was completely onto the state, how they want to go about it. So let's look at the state level of what is happening. So when these guidelines were published, a lot of the states were in different stages of conservation already. Now, some of the states who were well advanced, they were able to move fast. Some of the states who were not so well advanced and they did not require conservation because they did not go for any federal funding, or they did not felt the need, they are sort of behind. So the graphic on the right gives you a picture of what is happening at a state level. I mean, category 3 and 4 are very soft. Category 2, which is the green bar, these are the states where conservation is recommended. So these states would have some sort of a conservation program, which means they will be employing some practices, policies, or some measures to achieve some conservation goals. And category 1 state are the states where planning is required, where they have mandated that you need planning to achieve conservation. So let's talk about the second aspect, which is okay, sorry. Before you go into this to the second aspect, let's go a little bit deep into the state. So for California and Texas, the two states that we cited in the very beginning. You can see the degree to which they comply with the guidelines is variable, although these are the two states who have the best conservation programs across the United States, more robust and quite effective. So California, for instance, requires an urban water management plan every 5 years with requirements of conservation. On a comparison, you know, Texas doesn't require that. But Texas requires some sort of an audit every 5 years. And for utilities with 3,300 connections or more, they require annual audits. So both of the states have, you know, stringent conditions more than the federal, you know, code for plumbing standards. So they have gone much more beyond what the federal code says, and which means that they will have efficiency faucets, they will have measures to sort of effectively use water based on you know the gadgets, based on the metering, based on certain aspects that is more physical in nature. So let's see what are the instruments. You know, these are the legal sort of things. We saw legal things. So now let's talk about, you know, what sort of instruments we have. So this is a graphic which is created based on, you know, the EPA guideline document. The EPA says that conservation is a 9-step process. And it's very logical, it's very simple. If you start from the far left, it says you have to specify your conservation goals, which essentially means what exactly you want to achieve. And this goal can be as simple as I needed a big reservoir for water, raw water supply in the year 2025. Now, if I go through a certain conservation program, this reservoir could be deferred by a few years. So the goal could be like deferring this capital improvement project, which is a reservoir, by let's say 10 years. Now, what do you need to do in order to defer it by 10 years? So that could be an example of specific goals. Now, once you define the goal, you need to have a couple of other steps, which is like assess your system. What is the population you have? What are the peak demands? What are the average daily demand? How many are industrial users? How many are commercial users? So on and so forth. Then we talk about forecast. So between, let's say we are in year 2020, between year 2020 and 2050, what is our forecast? Are we increasing at 3%? Are we increasing the demand at 10%? Are we increasing at 20%? How does the forecast look like? And all this is, demand forecast is an essential step for water supply planning. And then, you know, the fourth step is you look at what you have already planned. What is the plan? What are your planned facilities? For instance, we talked about a reservoir. So that's a planned facility. You have planned it to come online in a certain year. Let's say 2040 is the year that you want this online. So that's the planned facility. And then we talk about, okay, what are the different conservation measures that we can implement? Okay, so there is a whole lot of measures out of which you select few. And, you know, to select few, there is a process. I'm not getting into the detail, but then you need to engage all the right stakeholders to say, okay, these are the 50 measures that we have shortlisted, and we want to look at these 50 measures or these 10 measures in more detail. And when you do that, you put some analysis, which will essentially be a cost benefit type of analysis, which is your sixth bullet. So you do that analysis and say, okay, these are the measures that provide me the maximum benefit per unit cost. And you select those benefits. You select those measures. And once you select those measures, you develop an integrated plan, which means you reforecast your demand, assuming certain percentage of implementation for those measures. And then you develop a strategy on how you're going to implement it, and you start implementing it. Now, this is more of a cyclical process, so it doesn't happen that you do this while on this graphic, it is shown as linear. It's not linear. I mean, you do it in a circle. You do certain things, you come back and you do it again, unless you achieve your goals. And your goals also could be, continuously improve it. So, for instance, right now, you may say that you want to defer the reservoir by 10 years. 5 years later, you may say that, okay, I want to defer it by another 10 years. So you look at a set of measures, you revisit those, and continuously improve that. So this is the conservation planning process, which is identified by EPA in its guideline. Now, obviously, the one that is advanced, I mean, if the utility is in the intermediate or in advanced sort of measure, they will take all the 9 steps. But the utilities who are following the basic guidelines will not do certain measures, certain steps. And these are shown on the slide with like white dots. Now, talking about measures, the picture that comes to your mind is, if you move from left to right, it is kind of a progression. You are at a basic level when you're doing certain things. You move on to the next level, which is the intermediate level. And then you go to the third level, which is probably the highest level, where you have the most stringent measures. Now, this is an important slide to understand what we mean when we start talking about reuse and recycling in the very first step. How many times we talk about this when we see conditions in summer months? It's very common. But you can appreciate that how flawed that assumption is, that you can actually achieve those, because unless you have the basic and intermediate levels in place, you cannot move on to the advanced measures. So some of the basic measures that probably we should be talking about if we are in the very beginning of our conservation program is like universal metering. Are we metering the supply? How effective is that metering? Are we thinking of moving to an automatic metering system? How often our meters are calibrated? How much data we are gathering to substantiate that we have a water loss management program in place? Do we know where this water is going? Are our mains leaking? Things like that. Now, the next level probably would be, if you have all these systems in place, the next level would be water audits. So water use audits means you will be looking at patterns on how your customers are using water. Are they using it within a specific duration? For instance, 8 p.m. to 12 p.m. Are they using it, is the use pretty much uniform across 24-hour period? Now, there is an interesting example from Virginia that I would like to share. And I remember working with a utility where they had significant peaks at around noontime. And the utility managers were scrambling to find out like why around noontime you get peaks, because that's very unusual time for any utilities to peak. So they tried to monitor and they found out that this is the time when people want to irrigate their lawns. And the reason why they were irrigating their lawns so much, because there was another ordinance within the same utility, and that ordinance required people to maintain greenery in their lawns. And if they are not able to maintain a certain level of greenery, like grass and plants and stuff like that, the ordinance stated that they are going to penalize people, and it was a financial penalty. So people got scared of the financial penalty and they started irrigating their lawns more often than they used to. And they chose a time which was like, okay, this is the time when I'm done with all my routine jobs of my day. Now is the time when I have some easy time, so I'll go and irrigate my lawn and just relax. So now those things were causing peaks in the system. So coming back to our subject, it's very important to understand what are the patterns. Now, if you start reading the patterns, you can probably be far more effective in doing a lot of conservation. Now, other measures in intermediate category could be, some sort of a retrofits or a pressure management measure. Now, pressure management is often used by utilities to minimize water loss if their system is not very tight. I don't think it is a measure that you should be using or relying long term. Essentially, if your system is leaking, you definitely need to think about tightening the system through some other means. But this is classified as intermediate measure. Retrofits would include retrofitting your gadgets, retrofitting your faucets, so that you can reduce the consumption of water. Now the third level, which is the more advanced level, talks about recycle and reuse, which is essentially a different sort of beast. But more than that, you would be talking about some water use regulations. So, which means that the water use becomes regulated. You have ordinances to dictate, that water will be used in a specific way, in a specific time. And you have a whole lot of, public commitment to really meet those numbers. Now that's where you talk about integrated water resource management, where you're thinking about utilizing all the sources of water, which is like your stormwater, your wastewater stream, any water imports, including alternative water supply, which is like recycle, reuse, or desalination. Everything mixed together to come up with
Hey, Owais,
a plan.
somehow we have lost your voice. Are you there?
Yes, I'm here. Can you hear me?
Owais?
Yes. Can you hear me? Hello. Hey, Rajesh. Hey, Rajesh, can you hear me?
Yeah, OS, we can hear you. This is Vimal from Mumbai.
Okay. So, Rajesh, you are the only one who is having some problem.
Rajesh sir, you are not audible.
Okay, so I will continue. Probably Rajesh will fix something on his end. Okay, great. So basically, three level of measures, and just remember this graphic. It kind of gives a good perspective of where recycling is and where metering is.
Yeah, I think Owais, we have lost your voice. Looks like. Can you just check the audio? Vimal, can you hear me?
Yes, sir. Now I can hear you. Now OS is not audible.
Can you hear me now?
Yeah, we can hear you.
Okay. So Rajesh, are you able to hear me? Probably there's some problem at your end, Rajesh.
Rajesh sir, your mic is on mute.
I think everyone can hear me, Rajesh. So let me just continue. If people are not able to, they will message you. Okay. So please message Rajesh if. Okay. So what I was saying is, please remember this graphic. It kind of gives a good perspective of where recycling is with respect to metering. So metering being the first basic type of thing, and recycling being the higher end of the conservation. Okay. So these are the tools that we talk about. Now let me just. Okay. So now we covered legal and instrument. So let's talk about community. Now, community essentially constitute of the users as well as all the stakeholders. So it's not just the consumers who are drawing water from your system. It will be pretty much all the stakeholders that are affected, or they draw some benefit, or they can probably impede getting you that benefit. So all those stakeholders become a part of the community. Okay. Now, how do we basically engage communities? So community engagement is a very, very specialized subject, and it typically requires a very detailed community outreach plan, which basically is a 4-step process. The first step is you need to initially engage the community. So when you go and talk to the stakeholders about water conservation, they will definitely not understand what you're trying to do. You'll have to sensitize them. You'll have to establish a channel of communication. You have to build that relationship. Sorry. Now that is part of the initial engagement. Now, once you get comfortable in that channel, you try to educate them. You try to understand what they understand about water, what they understand about conservation, what are their, apprehensions, what they envision as challenges. And when you work through those challenges, you discover that, the perspective on very technical issues is very different. For instance, we talk about lawn irrigation. We talk about an example of irrigating lawns at a certain specific time. Now, when you talk to the people, for instance, there is a person who is the head of the family. He or she has like 50 different tasks to do. Now, their life has a very fixed schedule. And as soon as you think about changing that, you're shaking their life. So you have to just understand what their concerns are and how effective it will be if you really do not listen to them. So you have to sort of document their concern. You have to understand their concern, and then you need to be prepared to talk about alternatives. Okay, what if I do this? Okay, this is not acceptable. This is a big challenge. What if I do this? So this is a give and take, but the focus of this discussion should be your conservation goal. Remember, the measures are just means to get to the goal. So the goal has to be really sold, and it has to be bought in by all the stakeholders. If your stakeholders have not bought in that particular goal, then there is a high chance that all the measures that you talk about or you implement are not going to be effective. Now, once you have that level of education achieved, you have to go through some detailed engagement. Typically, those engagements are done in large groups, focus groups, where you have workshops, where you have discussions, where you get their perspective, where you present alternatives, where you build some consensus and say, okay, this is what we are going to do. And once you do that, you iron your goals, you create some partnerships, and some people who are going to be your ambassadors. So it is a process, and it requires a whole lot of effort and a whole lot of time. Now, this is a part which is extremely critical, whether it is a conservation program for water, or it is any program that you're implementing where the community engagement is essential. So be it a recycle program, be it a waste management program, these steps are somewhat essential. Now, in terms of AWWA, encourages public involvement at a very strategic level, and it says that people should be bought in at every step, especially they should be part of decision making. So this is something which we will see through some examples of how people have done it. Okay. So I would like to move on to some global examples to really demonstrate how they have used community engagement and what they have done so far. So the first example that I've chosen is groundwater replenishment scheme, which is Orange County in California. Now, this is one of the flagship programs that came in effect, and it remains one of the flagship and leading programs across the world. Now, it's important to understand what is the history of this program and how this came in effect. So I'll briefly talk about it. So it goes back to 1965 when this thought was conceived. Now, the reason behind that was this particular county, which is Orange County, is a county in Southern California, and it draws its water from a large groundwater basin. Now, this is probably the only county which draws water from groundwater, and all the other adjoining counties, they rely on imports. Basically, they take water from Colorado River, which is further north of the state, and the cost of imports to those adjoining counties is very, very high, because it requires large infrastructure, and plus you're competing for the same resource on a large river. So if you want a certain amount, it's not necessary that regulators will grant you that amount of water. But this particular county does not take water from Colorado rivers, so they are relying on groundwater supply. Now, in 1965, they realized that they are having some saltwater intrusion from the sea into the groundwater, resources. At that point, they became alert and vigilant, and they started thinking of what could be a way to prevent this intrusion. So Orange County Water District is a water sort of utility, is a water utility. There is another entity within the Orange County, which is Orange County Sanitation District. They are the wastewater arm of this county. Now, in 1965, Orange County Sanitation District were implementing their first secondary treatment plant. And since they were implementing that secondary treatment plant, at that time, the cost of secondary treatment was very high. So they had this appreciation that they should not waste this stream of water, which is treated to a good degree. So they started looking into aquifer storage recovery, which is basically storing water in the aquifer for later use. And at that point, they did some studies and figured out that you cannot really put this water, the secondary treatment effluent, in ground without tertiary treating it. So they need tertiary treatment to prevent septic conditions within the aquifer. So all this was going on in 1965, which was about 55 years before. So Orange County Water District and Orange County Sanitation District, they started having some discussions around that time. And in 1971, they agreed to carry a program, which is a pilot program, where they can use water from the treated, water from the wastewater treatment plant, treated effluent, and use it as a saltwater barrier, which essentially will not be equivalent to a recharge into the aquifer, but it will be more on the periphery of the groundwater resource to really fight the intrusion of seawater into your groundwater basin. Now, this was the pilot program that was developed and implemented in 1976. So for 5 years, they tested extensively on what sort of treatment they need, and they finally implemented it. And that remained there until like 2004. So until 2004, essentially all the effluent that was coming out of the treatment plant, wastewater treatment plant, was used to fight the seawater intrusion into your groundwater basin. And that project was known as Water Factory 21. Now, Water Factory 21 was a famous landmark where people used to visit nationally and internationally because this was the first scheme of its sort. Now, in between 1976 and 2004, there are a lot of things that happened. California started facing challenges related to water import because a lot of people started importing water from Colorado River. So the water in that basin also became not so easily available. There were severe droughts that happened in California during this period. There were a lot of talk about conservation that started happening, and there was population rise within Orange County, which means they needed more water. So all these drivers, were slowly picking up, and by 2004, Orange County started thinking of something else, doing something else, and which will become what is known as Groundwater Replenishment Scheme, GWRS. Now, what GWRS is essentially they have enhanced that concept that they used in saltwater intrusion system, which is Water Factory 21. And after a lot of study and testing, they use the water for aquifer storage recovery as well. So essentially, 30% of the water would be used to fight the saltwater intrusion. 70% of the water would be recharging to the ground for use at a later stage. Now this becomes an indirect portable reuse project. So over a period of time from 2008 until today, I think it has gone through 2 expansions. The original capacity in 2008 was 265 MLD, which was later increased to 378 MLD in 2015. And I think the final phase that they are commissioning now will bump it up to 492 MLD. Now it consists of membrane plus RO plus UV technology. And all these things are more technical in nature, but let's come back to our subject of community. How did they tackle community? So obviously, the first thing that you will appreciate is the program started in 1965. They did not do anything till in 1971. From 71 to 76, they were doing pilot testing. So in 76, they actually implemented it. So 11 years, there were discussions, testing, talking to public, talking to stakeholders, seeing what is the best way to move forward. Now from 76 to 2004, it was not about non-potable reuse. It was all about fighting saltwater intrusion. So again, all the things that I talked about were happening on the side: drought, increase in demand, climate issues. But the focus was, okay, how can we bring public on board before we go for a recharge? So their outreach included, talking to government, talking to business leaders, talking to public, creating a S2O university online. And let me just quickly show you the website of OCWD to just give you some idea and appreciation of how they have really put together things and how transparent they are. Can everyone see my screen?
Yes.
Okay. So I'm not going to walk you through this website, but you can, if you go on this website, you'll find a whole lot of stuff, including information about process, information about who is steering this, a lot of reports, a lot of committee meeting notes, a lot of campaign related information. And at the same time, you'll find a brochure which is like this, which came out in the final expansion time. Some handouts which are just one pager, which just consist of all the information that people would expect to know in 90 seconds. Okay, so what is the product? What is the status? What is the cost? What is the timeline? Are there any jobs created? Look at this. I mean, it is basically cutting a wide cross section of people. So basically, this is all what is community engagement. Now, beside that, they have guided tours, they have newsletters, and there are a lot of reports that they send on a routine basis to the community, to the stakeholders, to keep them informed of what the status of this program is, how they're doing, what are their present next steps, how much benefits they're drawn, what are the concerns raised by others. And one of the things that is intriguing about OCWD is they have a bilingual website which means there is a big number of Spanish-speaking population in California. So they have a website set up in Spanish where they can see all this stuff in Spanish. So basically, it's all about taking everyone together when you're doing something of this nature. Another example, and I'm running out of time, so I'll be rather quick here, is NE Water, which is the story of Singapore. Now, Singapore historically imports water from Malaysia. Their agreement is going to expire in 2061. And there was a lot of political discussion around this water and how they get it from Singapore and compulsions, but I'm not going to get into that. But way back in 1970, which is about 90 years ahead of the expiry of that agreement with Malaysia, Singapore came up with a master plan, and the master plan had a strategy. Now that strategy was, to drive, the water supply based on 4 pillars. One is desalination, other is recycle and reuse, third is import, and fourth is rainwater harvesting. So they identify these 4 different ways on how they're going to meet their future demands. They kept the import with Malaysia. They didn't completely rule it out, but they tried to, become more reliant on other sources. So in '74, they came up with a pilot program, pilot plant at Jurong, which was about 45 MLD at that time. That was designed by Black Veatch, Guinea partners at that time. And it remained operational for about 30 years. Now it was supplying low-grade water, and at that time they used that water for non-potable purposes, which means they were supplying that water to the industries, primarily semiconductor industries, or they were using that for chilling plants and stuff like that. Nowhere they were using that water for potable or indirect potable reuse purposes until 1998. Singapore constituted a study. They constituted a panel of experts from multiple sort of disciplines to study the viability of recycled water for non-potable reuse, for indirect potable reuse, I'm sorry. Now, based on that study, the first plant came up in 2003. The first plant was Budok, 81 MLD. And ever since they have come up with more plants. There are 4 more plants that have come after that. Changi 2 was the last expansion. Now the plan that they have is they want to move their water supply to 55% of their water supply to indirect potable reuse. So a lot of the water that coming out of these plants is being fed to large reservoirs, raw water reservoirs, where it stays for a long period of time before it actually comes into the stream where it is treated and taken for potable purposes. Now there also the campaign, the community engagement was very interesting, and it was built over a large, many years. They built their campaign primarily on the success of GWRS, which is the Ajat project. So the program that they had initially was to fly some people. They used to really do this in groups. They used to gather some people in groups and fly them from Singapore to California, show them what the Water Factory 21 and how it is working, and really make those people as their ambassadors. So when they come back, those people will interact with other people and educate them about what they have seen. And the other people will trust these people more because they're part of the community. Now, there is a whole lot of things that they did, including, very fascinating brochures and a very good website again. The thing that these guys did in addition was they created a visitor center, which is very modern facility. I mean, if you walk into the visitor center, you will not realize that this is for a water utility. It is very sophisticated, and they give guided tours. They show you movies. They basically educate you with a whole lot of stuff about recycling water. So to wrap up the community part, you need to involve communities to a lot more extent, not just by feeding them with information, but engaging them, educating them, making them your ambassadors before you actually start seeing the benefits of conservation. So moving on to the institutional aspect. Now, this is another important aspect for any water conservation program. It is about, having a set of people, an organization that is going to drive this program, that is going to conceptualize this program, drive this program, not only internally within the organization, but also externally. It also entails functions such as collaboration, monitoring, advisory, and all this is really geared to earn trust. Once you earn the trust of the community, you have achieved more than 50% success. So what essentially these means is you have to have a set of people who are dedicated to this cause, who will come up with plans, who will come up with policies, who will come up with measures, who will interact with the government, who will interact with the regulators, who will create this program, who will drive community outreach, who will collaborate with any other agency, for instance, OCWD and OCSD, two agencies, and who are the owners of these programs. So let's see what these functions are with respect to the two example programs that we have seen. So in California OCWD, there is a steering committee. The steering committee, and you can go on the website and see who are the members of the steering committee. There are 6 members of a steering committee, 3 from OCWD and 3 from OCSD. So these are people who are responsible. They're not only responsible, but they're also empowered. They are the senior most people from these two organizations. They have all the authority to move things within the organization, within their own organizations. Now, they are the one who constituted the programs. Now, if you look at Singapore, the configuration is a little bit different. They have an independent panel, and the panel consists of a whole lot of other, disciplines. It's not just engineering. You have biomedical people, you have microbiologists, you have people from chemistry, and if you really look at their website, you'll find that these are not just people with this background. These are people who are authorities in these fields. So they are researchers with like 30, 35, 40 years of experience who can talk with authority on this subject. Now, these are the people who are developing this program. So there is a whole lot of thought put in place to constitute these steering committees or expert panel. Now, that is where, the success lies. In terms of monitoring, both of these have different type of monitoring mechanisms in California, but both are independent. So independent audit is kept for probably one reason, that if you have an independent agency doing an audit, it is going to be A, transparent, B, it is not going to hide anything, because it is an issue. Water is a subject which which is very close to public health. So if there is anything, any toxicity, any threat to the public health, probably this independent agency would flag it even before it reaches the public. Similarly, you have testing programs. So what these two programs have in common is they have an extensive test protocol. So for instance, in California, they have an online laboratory which picks samples on a continuous basis, and it monitors more than 500 parameters. Just think about 500 parameters. The safe drinking water standards in US has a primary list and a secondary list. They do not have 500 parameters. But these people, this OCWT, they are monitoring 500 parameters. And why they're doing it? First, they want to be absolutely sure that they're not putting anything back in aquifer which is not contaminated. Second, they want to earn that trust, that community trust. Once the community is comfortable that yes, these people are doing more than what they should be doing, they obviously are sold out on this. Likewise, you have a health effect testing program, which is a continuous program based on toxicology, where they keep doing experiments on mice and fish using the water and keep recording the findings. And at the same time, in Singapore, they're doing testing. They've done more than 150,000 tests to make sure that they're not putting anything in the reservoirs that is a threat to public health. Now, in both the cases, the water exceeds WHO and the standards. So the institutional part is very important, and I cannot lay more emphasis on that. But institutional and community sort of goes hand in hand. If you have a strong institutional setup, probably it is going to drive the community program with a lot more success. Now, I'm going to come to the last few slides on financials. Now, when we talk about financials, there are two aspects that we need to address. One is the funding. For any conservation program, you need money to implement. So where are you going to get the funding? Now, it could be a funding from the utility itself. It could be a PPP type of an arrangement. It could be a funding from the state, or it could be a funding from the center, or it could be a private party, just investing and taking over your system. I mean, there could be multiple ways, but whatever measure you think, it has a cost associated with it. And someone should be ready to invest. And that is what needs to be discussed as a part of the financial aspect of the program. Now, the other aspect, which is also very, very important, is the rate structure. So when we talk about rate structure, we talk about, tariffs. So what happens is, if you talk about conservation, you're talking about reducing water demand to a certain extent. So you're conserving the water. Now, what it is going to do is it's going to hit you on the revenue side. You'll not be, if you are a utility, you won't be selling as much water as you were selling before this conservation program. So your revenues will be affected. Now, in order to cover up for some of those and to cover for some investments, you will probably have to go with some sort of taxation or tariffs. Now, these tariffs could be a per unit or a lump sum, depending on what your financial model is, but it essentially doesn't come for free. you have to charge this to the public. Now that is a discussion which becomes often very tough and political, but it is an essential part. Otherwise, you will not be able to sustain this particular aspect. If you're not able to sustain the financial part, your program will fall apart. And to do that, many times you need to do a cost-benefit type of analysis. And when you do that, you have to monetize benefits which are not essentially monetary in nature. So you may have to look at social, environmental type of benefits, or you may have to look at the cost of capital. If you're deferring a particular capital improvement program by a certain year that you were supposed to do on a borrowed capital, essentially you're getting a benefit which is monetary in nature, which can be monetized. And then you also have to think about incentives and grants, because many times, the consumers can expect that in order to embrace a certain conservation measure, they may need some incentive, which could be a one-time investment. For instance, you go and provide them some support in terms of getting their building replumbed, for instance. If it is a single pipe supply and you want to go to a recycled water, you say, okay, we are going to replumb your building and the cost will be borne by the utility. So that would be a one-time incentive. But all that has to be factored in when you're talking about the cost of the program. So in this regard, there is a resource that I would like to draw a reference to. It's a survey that was done by Technical Education Committee of AWWA Americas. They did a survey of 19 utilities, and they found out that there's a lot of detailed information in the survey, but most of the utilities try to price recycled water as a percentage of potable water price, and that percentage was close to like 80%. So for instance, if you're selling potable water at $1 per gallon, the price of recycled water would be kept lower than that, maybe at like $0.8 a gallon. Okay. So I'm not going to go into the details of the survey, but that's a resource that you can refer to. Now, very quickly, I would finish with a comparison of financials of the two programs. California, the program was funded by the public agency, OCWD. They did not go for funding. The cost for the commission cost for different phases is listed on the slide. The cost of production was about 68 cents, which is like 68 pesos in US per meter cube. They did not go for any tariff at that point. Probably they will consider it in future, but somehow they absorb the cost, I believe, to the best of my knowledge, and I may be wrong here. For Singapore, the funding was a mix of government and PPP. The last few plants were PPP. The initial plants were owned by the government. The cost details are given there, but the key part here is they imposed a conservation tariff on the water. So all the users would see this as a part of their water bill in their monthly billing cycle. So that is how these two entities did it. Now I'll try to summarize our discussion here with this slide. Basically, water conservation entails a synergy of the 5 key elements that we talked about. While the legal part varies across geography, but we did see that in the United States, at a central level, there were guidelines. At the state level, there were variations. Some were following it as a mandatory thing, others were not following it to that extent. Talking about instruments, EPA defines it as a 9-step process, but ultimately what we see is community drives it. There are 4 steps of community engagement that we saw, and we saw that people in California and Singapore have done it very, very nicely, and they are the best examples available to the world. Institutional aspects, leadership is very important. Financially, it can vary, but 2 aspects are important: where you're going to get your money from, and how much tariff you are going to charge to your consumers. Now, this was my last slide. There is a takeaway slide which is up for discussion. I will not say where we stand on these. This is for you to decide. But these are the 5 instruments that we talk about. These are the 5 key elements. You can decide for yourself where we stand on these 5 elements as a country. And if we really have to do water conservation, we need to get our house in order and fix these 5 things at a minimum before we can start seeing any benefits or anything moving on ground. Now with this, I'll open this for discussions. If you have any questions, feel free to ask.
Owais, can you hear me?
Yes, I can.
Yeah, wonderful. So thanks a lot for that brilliant presentation, Owais. I think it covered the subject pretty much in detail. Maybe I can quickly start with one question from my side. You had a slide where you showed the 3 phases of development of a plan, basically, right? Based on the US EPA framework. Now, assuming that you have you have a scenario where you are at level 1, okay, or the government is attempting to get to level 1 or complete level 1 by setting up systems, water counting. It can be in a very crude format also, but something is there, okay, or not much is there, but they are actually making an attempt. But then that particular zone or area actually is struck with severe droughts. Now, are you suggesting that it is not prudent in such situations where the locality is actually, or the municipal corporation is actually at phase 1 or level 1, to jump on to undertaking reuse, recycle at all, if that's an alternative still available? So is that what you're suggesting? Or I mean, for example, if somebody decides that can we leapfrog from level 1 directly to level 3? I mean, there are sort of 2 reservations over here. One is the amount of time needed to go from level 1 to a level 3 measure, and the amount of cost involved in this. So how does a municipal corporation or a local area, maybe a district place, deal with that kind of challenge? And in that case, are you suggesting that recycle reuse is not an option to consider at all?
So, Rajesh, thanks. This is a very good question and very relevant to what we see in India, because we see that every municipal talks about recycle and reuse every now and then. Now, I would go back to my earlier slide on the 5 elements, okay, to respond to that question, okay? So these are the 5 elements that you need in place before you talk about any conservation measure, okay? Or in order to have any conservation measure implemented effectively, you need these 5 elements at a minimum, okay? So what you're talking about recycling is just one element, which comes under instruments, okay? Now, if you're picking just the instruments and leaving behind the other 4 things, how do you envision this to be successful? You do not have any regulations driving it. So people will not want to accept that water. They may have questions on the quality of water. They may have reservations about bringing treated sewage within their households. They may have reservations about public health. They may have so many, discoloration of faucets. I mean, a lot of the plumbing gets discolored and corroded sometimes because the water is not appropriately treated. So, and then, there are a whole lot of practical issues. Most of the buildings that we have in India, they are designed with a specific, to operate in a specific way. For instance, a lot of the buildings have an underground tank where most of the supply comes in. They pump it to an overhead tank from where the water goes to different user in a multi-story building. Now, when you talk about, hooking these users to a new supply, which is a recycled water supply, without educating them, without bringing them on board, without developing the program, without talking about financials, it is bound to fail. And to be completely honest with you, a lot of municipalities have tried it. I mean, I would not like to name one, but there is a municipality who presented in a conference recently stating that they have 900 MLD of recycled effluent up for taking. Now, just consider that approach. They have 900 MLD of recycling of effluent, which they want to give to others, but none of the 4 elements, legal, community, institutional, and financial, are being discussed, are being put in place. So you just have the measure alone. So it is not going to succeed. So to answer your question, whether they want to do recycling or they want to do, the level 1 measure, it is important that they make progress on all the 5 fronts. Now, unless they do that, none of the measures will take off.
Right. Yeah, interesting perspective. Thanks for that, Owais. Any other questions we have online? I am aware that we are running, we have already ran out of time quite significantly. Do we have any other questions? You can just unmute yourself and ask the question directly to Owais.
Yeah, I had one question.
Sure.
Yeah, Rishikesh, please go ahead.
So have you come across any case studies or example where such water conservation programs have been successful in developing nations?
Well, I can tell you that, I don't know how do you define developing nations, but the first direct potable reuse in the world was implemented in Namibia, which is not an advanced nation. And they were the first and only one for a very long time where they were actually taking treated effluent from their sewage treatment plant and making it go through a series of steps, maybe a 25-step process, and putting it back into their water supply. So they made it happen.
Okay, thank you.
Right. So I think with that, I will request people to just send out their email queries directly to me if there is anything still pending. And I sincerely thank Owais for a fantastic presentation. I'm quite sure we have all learned a lot from this session, and I'm quite sure that we will be able to understand and probably help some of our clients, some of our stakeholders understand how to go ahead with water conservation for a longer and better future. Thanks a lot, guys, for being a part of this presentation. Thanks a lot for participating. Again, I encourage each one of you to feel free to connect with me when it comes to any programs associated or events associated with IC. Likewise for IET as well. If you have any specific topics that you're interested to know more about, or would like to hear more a specific speaker to talk on a topic, feel free to approach me. I've already shared my contact details with you guys. So feel free to connect with me. And again, happy to meet you sometime soon with another interesting topic with an interesting presenter as well on that topic. And hope to see you all again. You all have a safe, a very good evening, a very good weekend. Please make sure that you don't touch your face. You clean your face you clean your hands. You keep your hands clean. Wash them regularly, and and keep yourself healthy from the COVID-19 spread right now. So take care and have a great weekend. Thanks a lot.